Good evening and welcome to Students Dominate Math. My name is Eric Hendricks. I'm going to be your math tutor for the evening. Please call in to the number 312-738-1060 and I'll attempt to serve as your math tutor for the evening. I can assist you in the areas of basic math all the way up through calculus, and my students at Providence St. Mel are beginning to talk about statistics a little bit, so I might be able to help you with some statistics as well. So please call in the number 312-738-1060. This is a live interactive call-in show. Works best when you call in. The way I run the show is I always come with my own topics in the event that you don't call in, and today is no different. Today I'd like to discuss a statistical topic, a topic called standard deviation. Maybe you've heard standard deviation before. We're going to talk in a little bit of depth as far as what standard deviation means. Let's present the topic standard deviation with the example that I have here. All right, so let's take a look. All right, so let's say we have one class number one. All right, today's topic we're talking about is standard deviation. All right, what does standard deviation mean? Maybe you've heard of that before. Standard deviation. All right. So let's say we got class 1, and let's say we got class number 2. Okay. With class number 1, let's say they take a test, and on the test, the first student gets a 90, the second student gets an 88, let's say the third student gets an 82, let's say the fourth student gets an 80, let's say the fifth student gets an 84. Let's say the sixth student gets an 86. Let's say the seventh student gets an 85. Let's say the eighth student gets an 89. The ninth student, let's say the ninth student gets an 81. All right, so we got 81, 89, 85. Let's say the 10th student gets an 85. Okay, let's see if I can zoom out a little bit. Okay, hopefully you can see that. Let's say we have another class. In that class, they get an 86, an 86, an 86. Another student gets an 86. Another student gets an 87. Another student gets an 88. The sixth student in this class, let's say they got an 82. The next one, let's say they got an 83. And then let's say the 8th, 9th, and 10th student all get 84s. Excuse me. 84s. All right. So we have two different classes. The first class gets a 90. The grades are 90, 88, all the way down to 85. And then the second completely different class than this one, they get an 86, 86, 86, all the way down to an 84. All All right, so today's topic is standard deviation. Now, let's say I'm a teacher, I am a math teacher, and I report to my supervisor. I say, well, the supervisor says, Mr. Hendricks, how did your students do? How did they perform on that test? And typically, what I would say, typically what you say to a supervisor is, well, the class average was so-and-so. The class average was, if the class average was 50%, that means they did very, very poorly. That means, how can I say, you add everybody's scores up and divide by the number of people who took that test. That'll give you an average. It gives the supervisor an idea, generally, how did everyone perform. Well, I completed the class average for both these classes. Before I started the show, I had actually completed, I added up all of these, I added up all of these scores, I added up all these scores and divided by 10 to get the class average of the first class, and the class average of the first class averaged an 85%. I added up all these scores divided by 10, and the class average was 85%. And I did the same here, and this class average was also 85%. All right. Both classes averaged 85%, but their scores were different. Let's take another look. See here, you had a score as high as 90, as low as 80 over here. You had a score that's as high as 90 and as low as 80. No one scored over 90, no one scored over 80, but over here, the highest score appears to be this person who scored the 88, and then the lowest score appears to be the person who scored the 82. So we have two different classes, but their averages were the same. The question that I would ask you is, which class performed better? Or more importantly, we need to have more information if I'm to communicate to, let's say, a supervisor, as far as telling them how did the classes perform. I hope you would understand how possibly more information besides the average, sometimes the average is called mean, sometimes the average is not, it's important, but it's not entirely clear as telling the whole picture as far as how maybe one class did versus another, especially if both averages were the same. So that's where this idea of standard deviation comes in. Standard deviation, there is a, let's just show you how we calculate the standard deviation. But what I have is I have a calculator, and with the calculator, I'm going to calculate standard deviation. All right, so the way that we would calculate standard deviation is for, let's say, this class right here is, I don't have a lot of room here, but you would take the square root of this score, 86, minus the mean, which was, I told you was 85, you'd square that, add to this score, 86, subtract the mean, and then you'd square that. You'd take this 86, you'd add that 86, you'd subtract the mean, you'd square that, and you would do this for every single score. You do it here, you do it here, here, here. You take this, subtract the mean and square it. You take that, subtract the mean and square it. You add it to that, subtract the mean and square it. I don't feel like writing it all out. You take each of the individual scores, subtract the mean, and add them all up and divide by the total number of scores recorded, which is 10. Okay? It turns out that I did this already. But the calculator, I'll show you how maybe you could put this in the calculator. Well, I'm sorry, my calculator's not operating right now, but fortunately, I put this into the calculator, and the mean, or excuse me, the standard deviation for this class, after you took each individual score, subtract the mean, I took the 86 here, I didn't write it, but you take the 87, subtract the mean, square it, the 88, subtract the mean and square it, they add it to the 82, subtract the mean and square it, and the standard deviation that we end up with is 1.8. 1.8. The standard deviation of this class is 1.8. And then if you do the same thing for this class over here, in fact, I'll write it down here. The standard deviation is 1.8. And then the standard deviation, if you took the square root of this score, subtract the mean, squared, this score, subtract the mean, squared, this score, subtract the mean, squared, and you do that over and over again, adding all those different squareds together, you would get, and then take the square root, you take all the different squareds, divide by the total number of terms, and then take the square root of that, you get a standard deviation of 3.2. 3.2. All right. So what does that mean? What does it mean? You can have an average score of 85. That both classes average 85. But what we want you to be able to do is, in communicating class averages, or really the average of anything for that matter, you can also find what's called the standard deviation. And what the standard deviation does is it tells you how spread out your, in this case, your scores are. It tells you what's called the variance, or again, how spread out your data is. The bigger the standard deviation, the more spread out your data is. You can have, similar to if your data is more spread out, the bigger the standard deviation is. If your standard deviation is very, very small, what that means is the data that produced the mean is more centered around the mean or the average. In short, the bigger the standard deviation, the more spread out the data. The smaller the standard deviation, the more centered your data is around the mean. So let's just connect that. Let's just connect that to the work we've done here. Notice how the standard deviation is 3.2. The standard deviation is 3.2. So what does that mean? And the standard deviation here is 1.8. Well, what that means is that the data here, because the standard deviation is greater here than over here, the data here is more spread out than this data over here. The data is more spread out. If the standard deviation for another class were even larger than 3, let's say the mean was still 85, but there was a standard deviation that was calculated that was even more than 3, let's say 10, let's say you had a standard deviation of 10, what that would mean is that a lot of students did very, 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 very well, and then other students did very, 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 very poorly, meaning that there is a significant spread in your data. Again, the larger the standard deviation, the more spread out your data is. So hopefully you understand what I'm saying. If there are any questions, whether it be on what I'm talking about now or the work that you're working on at your school, I'd love to serve as your math tutor today. You call the number 312-738-1060. I do have another topic that if you don't call in that I'd like to talk about, and that is something called a Z-score. Okay, a Z-score. You find Z-scores a lot of times when you're talking about normally distributed data. So from this point on, let's just assume that we're discussing normally distributed data. All right. So, and let's also let's use these same means and standard deviations in an attempt to talk about this next topic, Z-score. I hope standard deviation was clear. The bigger the standard deviation, the more spread out your data is around the mean. The smaller your standard deviation, the smaller the range of data is around your mean. If the standard deviation was, let's say, 0, what that would mean is that and the mean was 85. That would mean that everyone would have gotten an 85. There would have been no variance at all in the data. So let's say we have normally distributed data. Let's talk about something called Z-score, then we'll be out. All right, so normally distributed data produces what we call a bell curve. All right. And let's say we want to figure out, let's say someone got a 90. Let's say this person, or let's say 86. Let's use in both classes someone got an 86. So let's say we're working with normally distributed data and we want to find something called a Z-score. We want to find something called a Z-score for the student who got 86. All right, so the person that got an 86 in class 1, all right, the person that got a 86 in class 1, the way you'd find their Z-score would be you'd take the 86, you'd subtract the mean, which was 85, okay, and you divide by the standard deviation, which was 3.2. And let's do that for the person that scored, let's say the class 2 86. Class number 2, the person that scored 86, let's find their Z-score. So the Z-score would be that 86, this person who scored 86 up here. All right, this person has scored 86. And then you'd subtract the mean here. You'd subtract the mean here. Mean was 85, and let's divide by that that standard deviation, which was 1.8. You take the score, subtract the mean, divide by the standard deviation. All right, and in doing that, let me, I need my calculator. All right. I'm going to use my phone. I'm going to use my phone as a calculator. I'm going to use the phone, all right. I'm going to use my phone So we got 86 minus 85, and then you divide the 32. 1 divided by 32, you get 0.031. And then here, the 1 divided by 1.8, let's do that. 1 divided by 1.8, you get 0.555. All right, so the z-score of the person who scored 86 in the first class, assuming this is normally distributed, would be 0.031. The z-score for the second student who scored the 86 would be 0.555. So now what you're going to do is you're going to go to this z-score table with this information. All right, so you're going to go to this z-score table and you're going to look for the first z-score that we calculated was 0.031 and then 0.555. All right, so let's take our z-score 0.031. All right, so here is 0, and then we want 0.31 to be about right here. So we get a percentile of 0.6179. So let's write that down. 0.6179. We'll talk about what that means in a minute. And then we also had another z-score here of 0.555. So then we go to, we got 0.555. This would be 0.5 would be about right. Would be about right here. 0.6, 0.55. We got 0, and then we got 0.5. So you take horizontally here, and then you end up with 0.6915. 0.6915. And over here, I had 0.031. So we go to, you go 0, and then we need 0.3. So we got 0.6179. Okay, now what does that mean? How are you to use that? Well, what that means is the person who scored 86, the person who scored 86 in the first class, they scored better than 61% of the people in their class. So the person who scored 86 here, let me widen out a little bit. Oh, sorry about that. All right, so the person who scored 86 here, they scored better than 61% of the class. They scored better than 61% of the class. All right, they scored better than quite a number of people. All right, so we only have 1 minute left. But the person who scored an 86 in this class, their z-score was 0.691. The person who scored 86 in this class, they scored better than 69%. They scored better, their 86 was a little bit more impressive. The person who scored 86 over here, they had a more impressive score because their z-score was a little bit higher. They scored better than a larger number of students. So that's all we have time for. We thank you for watching. And remember, as you're putting forth your best effort in your classes, never quit. God bless you and have a good evening.